What modifications to standard GCMS were necessary to accommodate some of the complexities of working with the siloxane chemistry?
Now, I think this is where we needed to do some checks because if you look at the GCMS column, it's also made up of siloxane. And the reason it is made up of siloxanes as well, we're using the DB5MS column, and which has about 5% polydimethylsiloxane. So we needed to check to be sure that first the column will not like the matrix effect from the column will not act as an additional product of the siloxane. But for us to be able to do all of this, we added Pyrolysis GC-MS because analyzing just the sample, the siloxane sample, the silicon sealant sample, well, with GC, we might not be able to get what we need. So what we do is we subject it to high temperature without oxygen in what we call pyrolysis, and then break it down and see the different products that are coming. But before we do the pyrolysis GCMS, you're heating at a full range temperature, and you want to see the products that are evolving over time. But we don't have for us to be able to have a particular temperature focus. We then employed evolved gas analysis. This evolved gas analysis is like a fast screening technique that allows us to check at what temperature range we should be focusing on when we are doing the pyrolysis GC. So when we employ evolved gas analysis and the mass spectrometry, we rapidly screen through the sample we using a temperature, and then we will find a particular zone where most or all of the components of that silicon sealants are eluting. Then we will focus our pyrolysis at different steps within that temperature zone that we've seen with evolved gas analysis. So when we sequentially divide those temperature steps, that will allow us to carry out detailed analysis of those different components that have been evolved at different times.